we're trying to find x here. And remember, anytime we're trying to find x, what we're trying to do is asking the question, what x, if I put it into this equation, would make it true? Okay, so we're just trying to find the x value that would make it true. And we learned way back in middle school that to do that, we just get x by itself. And you know, we learned all these inverse operations back then. You know, if you see multiplying, you divide, and if you see subtracting, you add. But now we have logs, and how do we do inverse operations with logs? And oh, it seems so complicated, right? But it's not as bad as you would think. So what we're trying to do is we're trying to get x by itself. And whenever I have a log equation, I try to get it into this form. Log base b of my argument equals my exponent, okay? I'm going to try to get it into that form, because once I get it into that form, I can switch it into exponential form, and oftentimes that helps me get the exponent or the x all by itself. So let's do this. So this is log base 5 minus another log base 5, so I can use the quotient rule here to put them together, because right now it's not in the form that I want, right? Right now it's got two different arguments. So let's put these together. Okay, so we're putting these two together just like that. And you're going to be tempted to look at this and be like, oh, that factors into x plus 2 and x plus 2. It does not. Remember, this is the sum of squares, and sum of squares doesn't factor. It's not the difference of squares, so don't be tricked with that. Okay, so now we've got it into the form log base b of the argument equals the exponent. Now we can just switch it around into exponential form, right? So we have base to the exponent equals the argument, which is x squared plus 4 over x plus 2. And now this is something we've been solving for a really long time. It may look a little bit more complicated, but it's not. So 5 equals this red mess. So we're going to go ahead and try to get x by itself. We're going to multiply both sides by 5. So we have 5 times x plus 2 equals x squared plus 4. So let's go ahead and expand that. So now we have 5x plus 10 equals x squared plus 4. And now we just got to get x by itself. But you know, a lot of you guys will think like, oh, so we got to like subtract 4, and you're trying to get them on both sides. But remember, this is a quadratic. And how do we solve quadratics? Well, we either factor or use the quadratic formula. So we set them equal to 0, and then we factor or use the quadratic formula. So we got to get everything onto one side so that this is equal to 0. So right now I have a positive x squared plus 4. So I'm going to want to move all of this purple stuff over to the red side because it's so much easier to factor when my x squared is positive. So I'm going to subtract 5x and subtract 10 from both sides. So I'm going to end up with 0 on this side. And then I end up with x squared minus 5x. And when I subtract 10, I get minus 6. So now this is ready to factor or use the quadratic formula. Use either one you prefer. Factoring is sometimes faster, but the quadratic formula works every time. So how do we factor this? Well, this factors into x minus 6 times x plus 1. Because if I multiply that out, I would get a negative 6, and then it would add to negative 5. So that means if I set each factor equal to 0, x minus 6 equals 0, or x plus 1 equals 0 because of the zero product property, that means x equals 6, or x equals negative 1. Now we can check these to make sure that they're not extraneous by plugging them back in and just making sure that we don't get a negative number inside this log. That's the key, is just making sure we don't get a negative number inside the log. Because sometimes when we do a bunch of algebraic manipulation, we're going to get numbers that don't actually exist as solutions. Now if we plug this one in, we're going to get a positive number. If we plug 6 into this one, we get positive. So that's good. If I plug negative 1 into here, I get a positive number. And if I plug negative 1 into here, I get a positive number. So we're good. Both of them are solutions. So if I plugged in 6 or if I plugged in negative 1, I would actually get out a true statement. The left side would equal 1. All right, let's take a look at this one. And this one's already in that form that we wanted it to be in. So this is already in the log base b of an argument equals an exponent. So let's just switch it into exponential form and see if it helps. So we have our base to the exponent equals the argument. Okay, and now again, this is a quadratic because a quadratic is anything that has x squared in it. So that gives us 64 equals 2x squared minus 8x. And again, we need to get everything onto one side because it's a quadratic. So we're going to subtract 64 from both sides, and we're going to get 0 equals 2x squared minus 8x minus 64. And you're going to see that's 2, and you're going to automatically think, oh, I'm going to slide and divide. But remember, if you want to use a trick like slide and divide or rainbow, you need to take out the greatest common factor first because they fail when you try to use them without taking a greatest common factor out. I prefer not to use them at all, but to each their own. Okay, so here we pull out a 2 and we get x squared minus 4x minus 32. Now we can factor this. So what multiplies to negative 32 and adds to negative 4? Well, that's x minus 8 and x plus 4 equals 0. Okay, so then we set all of our factors equal to 0. Well, 2 can never equal 0, so we don't need to set that equal to 0. We have x minus 8 equals 0 or x plus 4 equals 0. So either x equals 8 or x equals negative 4. Those are our two options. And then we're just going to plug them back into here and make sure we don't come out with a negative number. If I plug in 8, I'm going to get a positive number. And if I plug in negative 4, I actually get a positive number as well. So both of these are solutions. So that means that if I plug in either one of those, I end up with a true statement.